Example 1 is with cylinders. The height of a cylinder with a radius of 4 centimeters is increasing at a rate of 2 centimeters per minute as the radius decreases at a rate of half a centimeter a minute. Find the rate of change of the volume of the cylinder with respect to time when the height is 10 and the radius is 2. So related rates means that multiple things are changing. They're related to each other, but they're not the same. So here, this cylinder is getting taller at a rate of 4 centimeters. It has a rate of 4 centimeters. Sorry, it's increasing at a rate of 2 centimeters a minute. So this is a rate, 2 centimeters every minute is how fast the height's growing. The radius is decreasing at a rate of half a centimeter per minute. So it's getting taller and skinnier. Now, find the rate of change of the volume. So that's what we have to find. Rate of change of the volume with respect to time when the height is 10 and the radius is 2. So we have this cylinder. It starts out with a radius of 4, but it's growing and it's getting taller and it's getting skinnier, and we're wondering what is the rate of change of the volume of the cylinder. So step 1 I said was find what you are given and what you need to find. So I would say we are given the rate of change of the height. So I'm going to call that dH dt. dH means the derivative of the height because it's a rate. It's a derivative. Derivative is rate of change of the height, and it is with respect to time because as time goes on, it is changing, and it is 2 centimeters per minute. All right. Now, it starts out at a height of 4, but it doesn't end at a height of 4, so I'm actually not going to use that. Next is this radius is decreasing at a rate. So I'm going to say dr dt, derivative of the radius with respect to time, is negative 0.5 centimeters a minute. And it's because it told us that it was decreasing, which means negative. The rate is decreasing at a rate of half a centimeter a minute. Then it says find, so I'm going to write my find. Find the rate of change of the volume. So that would be dV dt. Derivative of the volume, rate of change means derivative of the volume with respect to time. So dt on the bottom means it'll have a t in the equation. And then when the height is 10, so that's going to go on my given side. The height is 10 centimeters and the radius is 2 centimeters. So all my givens are on the left and what I have to find is on the right. So the first thing with these, you figure out what you're given, what you need to find. Second, you need to write an equation, and the equation has to have H's and R's and V's because those are all the letters that we were presented with. So H, height needs to be in there, R, radius needs to be in there, and V, because those are all the things we know and need to find. So we're going to write a formula, and we could write any formula that we want that has these letters in it. Because it's talking about volume, the easiest formula is going to be volume of a cylinder. Because volume of a cylinder starts with V equals, and then the volume formula is pi r squared h, volume of a cylinder, and I said that it had to have H's in it and R's and a V. So when you go ahead and do a problem like this, you need to figure out all that you're given, all that you're finding, and then you need to make sure that you include all those variables in your equation. So it's usually volume, surface area, something like that. All right, that was step 2. Step 3 is differentiate both sides. So I'm going to do the derivative. Derivative of V is dV dt. All of these equations are going to be in terms of time because this is not just a plain old graph on a Cartesian plane. It is a timed change. So as time moves forward, the thing is changing. The volume is changing. And so all of our variables, we will be doing the derivative with respect to time because we're plotting it on a graph that has time moving forward. Because this is a product situation, because we've got an R and a H, I'll have to do the product rule. So U, V prime, H, the derivative would be 1, and it had an h in it, so dH dt plus v times u prime, 2 pi r dr dt. Because this is not with x's and y's and in terms of x, because it's in terms of t, because we're timing this thing, all of our variables will have to have a thing multiplied after. So like v, times dv dt, h times dh dt, r times dr dt. So every single variable, you'll do the derivative and then tack on a d letter dt. Now, once you have your derivative of both sides, plug in everything you know. So we know dv dt, oh, that was in our find, so I'm going to leave dv dt. Pi r, I'm here, so r is 2 squared, times 1 times dh dt was 2, plus h is 10. I'm just getting that from my given column, times 2 pi r is 2, and dr dt is negative 0.5. So I got all the stuff that I needed to plug in from my given column, so I think it's worth it to write all that stuff down. Plugged it all in, and then dv dt is whatever this is when we simplify. So 2 squared is 4. 4 times 2 would be 8 pi, plus 2 times 2 would be 4, times negative half would be minus 2 pi. Oops, I wrote h here and forgot to plug in h, so I got to go back and write a 10 there. All right, so I'll go back. 10 times 2 is 20, times 2 is 40, times negative half would be negative 20 pi. So 8 pi minus 20 pi would be negative 12 pi. And because this is a volume and it's changing, I would say it is centimeters cubed, cubic because volume is 3-dimensional, and per minute because all of my other rates were per minute. So this would be my final answer.